Hi everyone, today we're going to start 1.5, day 1, which is rationalize. First we're going to start with some vocab terms. So the first term is square root. What is it? The square root of a number is the value that, when multiplied by itself, gives the number. So for example, if we have the square root of 4, I'm wondering what two numbers multiplied together would give me 4, and that would be 2 times 2. So the square root of 4 is 2. The next term is radical, and a radical is the expression that has a square root, cube root, etc., and it is the symbol, which it looks like this. That is a radical. And then finally, radicand, it's just the value inside the radical symbol, and it's the value you want to take the root of. So like our previous example, when we had the square root of 4, 4 would be the radicand. Next, we're going to talk about some of the properties of square roots. This is something that you did learn in geometry. So the first one is the product property. We know product means multiplication. All that means is that we can take our radicand and we can find factors. One factor, we want to have a perfect square. And what happens with our factors is that you can break apart radicals by doing the product of two different radicals. So if we look at our example here, we have the square root of 18. What perfect square is divisible by 18? Well, we know it's 9, and we know 9 times 2, that would give us 18. Well, the square root of 9 does simplify to 3, and so our answer then would be 3 radical 2. Quotient property. The quotient property just states if you divide any two numbers, you can split it into two separate radicals. One thing we really want to focus on are our square roots. So if we look at our first example here, the square root of 2 divided by 25, we split those into two separate radicals, the square root of 2 divided by the square root of 25. Well, we know the square root of 25 is a perfect square number, and that simplifies to 5. So radical 2 divided by 5 would be our answer. Now that may have been a lot of information thrown at you at once. So let's kind of review what our perfect square numbers are. So 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3 is 9. And we also have 16. 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So these are some perfect square numbers that you should memorize and you should know, but I would write them down in your notes, that way you have them for reference. All right, so simplifying radicals by breaking guys out of jail. What perfect square can break out? All right, so that's what we want to focus on, or what perfect square number is divisible by the radicand. And our first radicand here is 20. So what perfect square is divisible by 20? Well, we know 4 is a factor of 20. 4 is a perfect square. Well, 4 times what gives us 20? And we know that's 5. So now what I'm going to do is I'm going to rewrite this as my product of radicals. So I'm going to write the square root of 4 times the square root of 5. Remember, I didn't change the square root of 20. I'm just rewriting it in a different way. Well, now I have the square root of 4, which I know simplifies, and the square root of 4 is 2. So that 2 pops out of jail, but the 5 stays under the radical. So 2 radical 5 would be my answer. Square root of 18, we already did this one, or we already talked about this previously. But what perfect square number is divisible by 18? It would be 9. And I know that 9 times 2 is equal to 18, so I'm going to rewrite this as the square root of 9 times the square root of 2. Well, which square root simplifies? It's the square root of 9. We know the square root of 9 is 3, so 3 pops out of the radical, and 2 stays underneath. Let's try this again. What perfect square is divisible by 24? It would be 4. And we know 4 times 6 is equal to 24. So the square root of 4 times the square root of 6 is our product. Which one simplifies? It'd be the square root of 4, and that pops out a 2. So 2 radical 6 is our answer. And lastly, 50. What perfect square is divisible by 50? An answer I get a lot is that people put 5 and 10. Yes, 5 times 10 does equal 50, but 5 and 10 both are not perfect square numbers, so that's not going to help us break one of them out of jail. Remember, I'm looking for perfect square numbers, and the perfect square number that would work here is 25. I know 25 times 2 is equal to 50, so when I rewrite this, it's the square root of 25 times the square root of 2. Square root of 25 does simplify, and it simplifies to 5, so 5 pops outside of the radical, and the square root of 2 just stays out how it is. Next, let's work on some division. So I have the square root of 4 divided by the square root of 81. So the first step I want to do is I want to split this into 2 separate radicals. So this would give me the square root of 4 divided by the square root of 81. Well, the square root of 4 does simplify. It simplifies to 2. And the square root of 81 also simplifies, and it simplifies to 9. So 2/9 is our answer. Part D, I have the square root of 7 divided by 16. If I plug in 7 divided by 16 in my calculator, it's nothing pretty. So I'm just going to split this into 2 radicals. So I have the square root of 7 divided by the square root of 16. This time the square root of 7 does not simplify, so I'm just going to keep that as the square root of 7. It's not pretty. Divided by, and in this case my denominator does simplify. The square root of 16 is 4. So the square root of 7 divided by 4 is my answer. Next, we're going to talk about rationalizing the denominator. And when you rationalize the denominator, it's when you eliminate the radical from the denominator. In general, you are not allowed to have a radical in the denominator. If you see one, you need to simplify it somehow. And the way you're going to do that is by using the conjugate. So the conjugate is just the opposite. So for our first example here, I have a plus the square root of b. If I had a plus the square root of b, the conjugate, or opposite, would be a minus the square root of b. So in this table here, we kind of see what we would use if we see our denominator. If we notice our denominator is just a radical, we're going to multiply our expression by just the same radical. If I notice that my denominator is in the form a plus the square root of b, I'm going to multiply the denominator by the conjugate, which in this case would be a minus the square root of b. If I notice that my denominator is a minus the square root of b, to change that, I would multiply it by the conjugate, a plus the square root of b. So here are 2 examples here. Let's start with a. So a, I have the square root of 5 divided by 2. If I plug that in my calculator, I don't get anything pretty. So that means my next step is to split this into 2 radicals, the square root of 5 divided by the square root of 2. Unlike our previous examples, my radical here does not simplify. The square root of 2 is not pretty. So that means to get rid of it, I need to multiply it by the conjugate, which our conjugate is going to be the square root of 2. So what I do to one, I have to do to the other. So I'm just going to multiply this through. So I now have the square root of 5 times 2 in my numerator. And on the denominator, I have the square root of 2 times 2. When I simplify this, I get the square root of 10 divided by the square root of 4. And this time, the square root of 4 does simplify. We know that the square root of 4 is 2. So this simplifies to the square root of 10 divided by 2. Now, before we can say that this is simplified all the way, let's look at our numerator. Is 10, does that simplify anymore? Is there any perfect square number that is a multiple or a factor of 10? And the answer is no. So the square root of 10 divided by 2 is our final answer. Next, let's look at part B. So part B, I have 3 divided by, and in my denominator, it is 7 plus the square root of 2. So I need to get rid of that denominator, and the way I do that is to multiply by the conjugate. The conjugate here would be 7 minus the square root of 2. So what I do to the denominator, I also have to do to the numerator. So I have 7 minus the square root of 2 divided by 7 minus the square root of 2. So this then simplifies. I have 3 times 7 minus the square root of 2 divided by, and I'm going to write both of these in parentheses, 7 plus the square root of 2 times 7 minus the square root of 2. So now to simplify, in the numerator, I'm just going to distribute the 3 inside the parentheses. So 3 times 7 gives me 21, minus 3 times the square root of 2 is just 3, the square root of 2, divided by, and in the denominator, I'm going to FOIL. So this is going to be a little bit more complicated. So I have 7 times 7, that is 49. I have 7 times the square root of 2, and there is a negative there. So that is minus 7, the square root of 2. 2 times the square root of 7, that one's positive, so plus 7 square root of 2. And then radical 2 times negative radical 2, that is going to give me negative the square root of 4. All right, so let's simplify this even more. So the numerator is going to stay the same. I have 21 minus 3 square root of 2. If I look here, I have minus 7 square root of 2 plus 7 square root of 2. Well, those are just going to cancel out. And so in the denominator, I'm left with 49 minus, well, what is the square root of 4? We know that's really equal to 2. So now I can simplify this even more. 21 minus 3 times radical 2 divided by, what is 49 minus 2? It's 47. And I am done. Now what's nice is that I did not change my beginning number to my ending number. I just rewrote it. So you can always double check that this is correct by plugging this in your calculator and then plugging in what you originally had in the calculator. You want those numbers to be the same. If they're not the same, that means something went wrong. All right, so let's practice this again. So I look at my denominator, I see that radical 11. I know I can't have a radical, so I need to multiply by the conjugate. And since I have plus in the denominator, I know my conjugate is going to have a subtraction sign. So 4 minus the square root of 11 divided by 4 minus the square root of 11. So this simplifies then to 2 times 4 minus the square root of 11 divided by, and in my parentheses, I have 4 plus the square root of 11 times 4 minus the square root of 11. All right, so let's distribute in the numerator. That gives me 8 minus 2 the square root of 11 divided by, and in the denominator, I am going to FOIL. So 4 times 4, I get 16. 4 times a negative square root of 11 is negative 4 square root of 11. 11, the square root of 11 times 4 is a positive 4 square root of 11. And the square root of 11 times the square root of 11, you can just plug that in your calculator. You know that those radicals then are going to cancel, and it's minus 11. Now, the whole reason we did that is that so that we don't have any radicals in the denominator, and so those should cancel. If they don't cancel, that means you did something wrong. That was the whole point. So we see that those cancel, and we are left with 8 minus 2 square root of 11 divided by, I have 16 minus 11. That denominator can simplify even more. So my final answer is 8 minus 2 square root of 11 divided by 5. Here's our last example here. So I have -1 divided by 9 plus the square root of 7. Well, once again, I can't have the square root of 7 in my denominator. I need to multiply by the conjugate. And my conjugate this time would be 9 minus the square root of 7 divided by 9 minus the square root of 7. So this then simplifies to -1 times 9 minus the square root of 7 divided by, I have 9 plus the square root of 7 times 9 minus the square root of 7. All right, distribute that -1 inside the parenthesis. That then gives me -9 plus the square root of 7. I need to FOIL the denominator, so 9 times 9, I get 81, minus the 9 and then times negative square root of 7, that's minus 9 square root of 7. Square root of 7 times 9, I have to have positive because they need to cancel out. Square root of 7 times negative square root of 7 is -7. You can plug that right into your calculator. My middle piece does cancel out. And I have -9 plus the square root of 7 divided by 81 minus 7. Simplify the denominator once again, and -9 plus the square root of 7 divided by 74. That is my final answer, and I'm done.